Hello, this is Patrick at OneCNC West, and I'm very excited to be able to demonstrate OneCNC XR7. Now, OneCNC XR7 is a full-featured CAD CAM system that's very easy to use, very user-intuitive, and also very powerful. Now, why don't we begin with taking a look at the user interface. Now, the main center area, this is your main workplace, and this is where you're going to apply your CAD operations and your CAM operations. If you want to, you can start from scratch, create your geometry and apply toolpath, or you can also import geometry from other CAD systems and easily apply toolpath. On the left hand side of the screen, this is your main toolbar. This has all your CAD tools and your CAM tools. On the right hand side of the screen, this is a multi-purpose toolbar. You have your NC Manager, which allows you to work with your machining operations, and then you have an array of very powerful browsers located in the lower right hand corner. The Verify browser, History browser, Recent File browser, and a Layer browser. Very, very nice. Now, one of the unique features of OneCNC is the ability to work with multiple documents. So if we take a look here, you can see that I can open up the beam plate and I can work with this without having to open up another instance of OneCNC. It's very simple and very easy to switch back and forth between files. So remember, OneCNC is a multiple document application. In fact, you can even cut, copy, and paste geometry from one file to another file if you'd like to. Now, another unique feature of OneCNC XR7 is the ability to work semi-full screen or full screen. Now, what this does is provides the ability to take advantage of many different monitor sizes. Let me demonstrate. If I take my cursor over here to the left-hand side of the screen and click on this little button, you can see we can easily collapse that left toolbar. We can do the same to the right-hand side of the screen as well. Just simply click on that little button and that right toolbar will disappear. Now we can work full screen and we can utilize all of our drop-down menus, toolbars, or custom toolbar to get all of our CAD or CAM work done. This is a very nice, powerful feature provided by OneCNC XR7. Now let's take a look at the geometry side of OneCNC. I'm going to demonstrate how easy it is to create wireframe geometry, surfaces, and solid models, and also use hybrid modeling to create a part. I'm going to start by creating just a couple of circles here. I'm going to join those with just a couple of fillets. I'm going to turn the trim on. That looks very good. So nice closed boundary. I'm going to duplicate that closed boundary and scale it by 50% and drop it down 1 inch in Z. That looks good. Now let's create some surfaces from those two rails. I'm going to use cross section. Going to grab that rail and that rail, right click, and there we go. Let's use surface from curves now to create those cap surfaces. Going to grab that bottom rail, and let's do the same on the top there. That looks very good. Now ultimately I'm going to take those surfaces and create a solid model from those, and that's because I want to subtract that solid model from the main body. You can create a solid model by using the union command. Now you can see we have just one nice solid model. Very easy, very powerful set of tools. Let's create the main body. I'm going to use the line tools here, and I'm using coordinate input. And all you do is you type in the coordinates that you'd like and click the OK button, and then you can create the geometry. Now I'm creating the lines in order, but you don't have to do that. You can create the lines in any order that you'd like. Very flexible. You can use absolute coordinate input or incremental coordinate input. There you can see I'm referencing off of existing geometry, and here I'm just grid point snapping just to kind of speed things up a little bit. There I'm referencing off of that point, referencing off there, and right click to finish. Let's add some chamfers to this. It's very easy to do. You just left click and you're always digitizing in groups of 2 there. Creating fillets just as easy. I'm going to set that to 0.1875, and again it doesn't matter which order you digitize the geometry in. Let's create a couple of holes now. I'm going to create one there, change the diameter to 0.375. Again, I'm referencing off of existing geometry. There I'm grid point snapping and also changing the diameter of the circle. Now I want to create some cutouts. So these are going to be shapes that I'm going to cut out of the solid model. And that looks good. Let's make another one over there on the right hand side. That looks very good. Okay. And then what we're going to do now is let's extrude that main body. Okay, so let's go into our extrude tools. Going to use extrude curves. You can really drag that in any direction that you'd like. I'm going to pull that down to minus 0.8. That looks good. And now let's subtract that original solid model from the main body using difference. Very easy to do. Okay, now we're going to go back into extrude cut, and I'm going to start using those shapes to make our cutouts there. You can see that's also very easy to do. Using the extrude cut command, you can easily cut holes all the way through the model as well. Let's use extrude boss now, and we put a little taper on that. What's nice is that's just one solid model there. Very, very easy. Now let's use construction planes. Going to create a construction plane on that face and change my view so I'm normal. I'm going to create a cutout that we're going to cut all the way through. Now, when you're using construction planes, your geometry can be relative to the construction plane or they can be relative to the world coordinate system. So I just did a quick trim on that. And then again, we'll use our extrude cut, push that all the way through. Very easy to do. All right, so now what we're going to do is I would like to demonstrate that we can get rid of that wireframe geometry. We don't need that anymore, so I just selected by color, then hit the delete key. Let's create some fillets. Now these tools are for creating fillets and chamfers on solids and surfaces. So let's use our fillet command, set that to an 1/8 inch. Notice how OneCNC changes the geometry to translucent so you don't have to rotate the part to easily select the edges. Let's put a 200 thousandths fillet on that opening there on both sides. That looks very good. And let's go to chamfer now. We're going to put some chamfers on those holes. Again, OneCNC changes the geometry to translucent, so it's very easy to select those edges. That's very good. That's looking really good. What we're going to do now is we're going to create another fillet at the base of that boss. And why don't we demonstrate also how easy it is to, for example, alter the geometry. In fact, let's change the color of this shape to maybe a dark gray. That looks good. You can also identify or color individual faces using XR7 using the color surface command. I'm going to change the color of that inside cutout to blue, and that may signify that that needs a different surface finish. So that's a real easy, very versatile command within OneCNC. All right, so there you go. There is a quick example on how to create geometry using OneCNC. Very easy to create wireframe geometry, solids, and surfaces. And if you'd like, you can use hybrid modeling to combine all of those to easily create shapes. Very, very nice. Now, OneCNC also provides a very easy, straightforward approach to adding dimensions and text. Let's demonstrate using this new shape. I'm going to start by panning and zooming in just a little bit. Let's go back to our main toolbar. We're going to select dimensions. Let's go with a horizontal dimension. I'm going to simply left click that piece of geometry, left click that piece of geometry, just drag the location down and left click. And once I do that, I now have the ability to modify the attributes of this dimension. I'm going to say that looks great, so we're going to click OK, and there we go. Now let's give you another example. What we're going to do now is we're going to create a diametrical dimension. Going to left click here. Going to drag this down, and let's make some changes to that. So instead of just having the dimension, why don't we add something like typical for places? Very easy to do. And then when I click OK, you can see now that we have some nice descriptive text added to our inline dimension there. Very, very nice. Now let's take a look at another quick way we can add dimensions to a part. In fact, let's focus on a solid model. Now this can be quickly accomplished by using the pages command. So we're going to select pages. First thing we want to do is select a template. These are the predefined templates you can select from, or you can create your own templates if you'd like. I'm going to use that one and click OK. Now what we can do is quickly add different views of our solid model. In fact, let's start with the top view. There's a nice preview of the view. I'm going to use place view on page. I'm just going to take my cursor and left hand click there. How about a front view? So I'm going to select front view. Again, there's a nice preview of the view. I'm going to use place view on page. I'll use the alignment grid and just left click. How about isometric? Again, there's the preview. That looks great. Place view on page, and I'm just going to left click right about there. All right, so this is called page space, and if I were to use these arrows, I can easily move back and forth between model space and page space. Now the reason why this is so important is because you can make modifications to your solid model, and those modifications will show up within page space. In fact, let's create a circle here, and I'm just going to use the extrude cut command. Just going to cut a hole through there. That looks good. I no longer need this circle up here, so let's get rid of him. Now if we go back into our pages, that looks good. Let's bring our menu back up, and we can choose this option called Update Page, and what you're going to find is all three of those views are going to update with that hole. And there we go. Now the next thing you can do is you can add dimensions. Now adding dimensions to this is just as easy as adding dimensions to a 2D part. Let's demonstrate. Back over to the main toolbar, we're going to select our dimensions option. Let's start with a horizontal dimension. We're going to left click and left click, push the dimension up where you want it and left click. That looks good, so I'm going to click OK to that. I'm not going to dimension the whole thing. I just want to give you an idea of what it's like to add dimensions within page space. And you're going to find it's identical to adding dimensions within model space. So that looks good there. And why don't we finish up with a diametrical dimension? Let's grab that inner circle there and place that right about there. And that looks great. Okay, so that's using the pages command within OneCNC to quickly add dimensions to a solid model. Now let's take a look at applying toolpath to our geometry using OneCNC. Now you can apply toolpath to wireframe geometry, solids, or surfaces. The procedure I'm going to demonstrate is exactly the same within OneCNC mill, lathe, wire EDM, laser, plasma, or router. Let's first take a look on the right-hand side of the screen where the NC Manager is. That's where you store all your machining operations. You can see I've already performed a whole operation here. Now let's take a look over on the left-hand side of the screen within the CAM area. For milling, you have stock tool paths. These are your 2.5 axis tool paths. You also have model tool paths. These are your 3-axis tool paths. And then you also have simultaneous tool paths. That's your various 4-axis and 5-axis commands in there. Let's start with high-speed pocketing. We're going to select the geometry. This first dialog box, this is where you're going to select a tool. Now you can manually create a tool by typing in values, and as you do that, the graphics will update over there on the left-hand side. That's a very powerful feature within OneCNC. You can also select from a list of tool holders or manually or parametrically create holders if you'd like. That looks very good. Now if you want to, you can select a tool from the tool library by clicking on Tool Changer. Let's go with how about a 3/4 inch high speed end mill. And once you do that, the speeds and feeds are automatically calculated based upon the material you have. If I change it from aluminum to copper, you can see the speeds and feeds change. Let's put that back to aluminum billet now. I think that looks very good. Now let's take a look also at the feed control. First thing I'm going to do is change my turret position to turret position number 1. But let's go into feed control. Now feed control is going to reduce your cycle time as well as extend the life of your tooling. Let's demonstrate. Within the feed control, you can see that you can make the tool slow down as it approaches a sharp corner. And you can also make the tool slow down when it machines small arcs. You can control the size of the arcs and the distance before sharp corners over here on the left, and you can also control the percentage of feed rate that's going to be changed as well. Now once you do that, you can up these feed rates. In fact, I'm going to up this to 25 inches a minute, and that's because these feed rates are going to be applied to straight vector cuts and to circles that are larger in radius than what we've specified here within the feed control. Alright, so this is going to reduce the cycle time. Very nice feature. Let's click next. Here's a dynamic dialog box that shows our different clearances and different Z depths in that. For example, the rapid Z plane is represented by that red grid. So if I change that to 1, you can see that dynamically changes. Also notice that we're seeing our part in here, which is also very nice feedback. For Z depth, if you want to, you can select Pick Z and actually snap on the geometry, and OneCNC will populate the proper Z depth for you. These are the different types of commands or machining operations for pocketing. I'm going to use high-speed closed. By the way, high-speed machining is available in all the OneCNC mill packages. Let's click next on that. We're going to ramp in fact, we're going to ramp helix. I have my helix diameter set, my angle set. You can actually ramp in at any location within the pocket, but I'm going to use automatic for this. We're going to click next. All this looks great. My step over looks good. My depth of cut can leave 10 thousandths on the wall there. Don't need an extra finish pass. We'll let OneCNC generate the toolpath. Very nice, very quick and efficient. Now what we're going to do is take a look over here within the pocket operation, and I want to show you preview. I'm just previewing just that machining operation. This gives you a nice representation of the tool interacting with the geometry. Now if you want to see actual material being removed, what you want to use is simulate instead of preview. So let's go to simulate rest. You can use different types of stock. I'm using a solid model here, and there you go, there's our solid model, and you can watch the tool removing material. You can speed this up, slow it down, rotate, zoom in, zoom out, back plot, cross section. There's lots of neat things you can do inside of there. You can also turn these different operations on and off, and that will tell OneCNC to just preview or simulate just those operations. You can also easily reorder the operations by dragging them, which you can see here. It's also very nice. If you want to edit an operation, you can just right-hand mouse click and select Edit Operation. That looks good. All right, now let's apply a 3-axis toolpath. How about a planar finish command? So this works exactly the same way. First toolbox is where you're going to define a tool or selector from the library. You can dynamically change the values. I'm going to leave everything alone there. I think that looks good. Let's click next. I think our clearance values look good on this, so I'm going to leave that alone. All that looks fine. All right, so let's click next on that. I'm going to leave the toolpath angle set to 0, but you can change it to whatever you'd like there. We're going to just use a constant step over of 20 thousandths and climb cut. And for the boundary, I'm going to use pick. I'm going to select that boundary I made a little bit earlier and let OneCNC generate the toolpath. You're going to find that OneCNC calculates toolpath very fast, both 3-axis and 2.5-axis machining. Very nice and very efficient. Now let's take a look at simulating all the toolpath. I'm going to right-hand mouse click on the toolpath group, select Simulate Rest. We're going to use a solid model for our stock. There's our spot drilling. There's our CAN cycle, G83 for our drill, and CAN cycle G81 for the countersink. Here's our high-speed pocket operation. And of course you can do various things like backplot toolpath if you want to. You can zoom in, zoom out, rotate, whatever you need to do. Very powerful toolpath simulator and preview provided by OneCNC. Very good. Now let's exit out of this. Let's take a look now at creating some CNC code. So what I'm going to do is I'm going to double click on the toolpath group, select post group, and this time we're going to select our post processor. OneCNC ships with over 100 post processors. You can create posts and easily edit posts if you'd like as well. We're going to go with the Haas here, click save, and we're going to replace that file there, and this is going to put the CNC program within the text editor. Text editor is very powerful, provided by OneCNC. Lots of nice commands you can execute inside of here. There's also some various calculators as well. You can use the standard Windows calculator, but if I come up here and click, you can see there's also a nice calculator for helping with tool paths, RPMs, speeds and feeds, and things like that. Also note that the text editor also comes with full RS-232, so you can upload and download your CNC programs if you'd like. Now let's take a look at making a setup sheet. Those are called job sheets within OneCNC. This is very nice. This creates a PDF file. So let's view the PDF file. Let's zoom that up just a little bit. You can see that all the pertinent information, cycle time, what machine tool was used, the different tools that were used, some nice display here, some nice graphic overview of where the X0, Y0, Z0 is. And then each machining operation is broke down individually so you can see individual cycle times, the tools that were used, and things like the work offset, maximum Z depth, and so on. So very, very nice job sheet provided by OneCNC. OneCNC provides CAD CAM solutions for router, plasma, and laser, 2 and 4-axis wire EDM, 2-axis lathe machining, C-axis lathe machining, Y-axis lathe machining, B-axis lathe machining, 2.5-axis mill machining, 3-axis mill machining, 4-axis position machining, 4-axis wrap machining, 4-axis simultaneous machining, 5-axis position machining, and 5-axis simultaneous machining. Thank you so much for watching, and please contact if we can be of assistance.